Hello, today we are going to talk to you about the fact that gases certainly have density, and we are going to talk about the density of substances that are in the gaseous state. But the concept of density is a concept that is related to, for example, the gas laws and the equation of state of an ideal gas. And first, in order for us to understand how this quantity of density is derived, we will now need to talk about what is the painting concentration for a gas. The name paint concentration is the ratio of the amount of a substance and in relation to volume. Well, let's do the statement through formulas. It will be the ratio of N divided by V. Now, in order for us to take this further, we need to remember that we have the state of an ideal gas equations where we have pressure, volume, universal gas constant, temperature are related to moles. Let's see, from here we need to derive moles. To do that, that would be P times V divided by RT. Let's do a substitution here. Oh, and then instead of N times the amount of substance, we substitute P multiplied by V divided by R and multiplied by T. And divided by V. From here, it's easy to see that V and V in this case is at the top. In the numerator and in the denominator are safely reduced. And then what we have is that it would be P with respect to R and multiplied by T. That's the paint concentration for the gas. It's quite often used, but we need to come to density. What is density? And what is density with respect to a gas? So density is denoted by the little letter d. And it is a ratio, as we know, density is the ratio of mass to volume. But then it turns out that it's the ratio of mass to V. Now let's see, what do we have mass? Mass is the mass multiplied by the amount of substance. Then we'll make a substitution. In this case, we will take the amount of substance also from the universal equation of state of an ideal gas. And then from the top we have, instead of M, we substitute the mass of paint. E multiplied by the amount of matter, and the amount of substance we have deduced with U above. That would be P multiplied by V. And accordingly divided by R times T and divided by volume. And then it turns out that V and V are reduced. And we'll end up with the mass multiplied by the pressure. And then at the bottom we have R and T. And that's how we get the value for density. This is the formula that we're going to use in the problems. So we've derived two formulas. The first formula is the formula for the molar concentration of a gas. It's the ratio of the pressure of the universal gas constant in temperature, and we're going to use the density of the gas. And this is the ratio of the paint mass multiplied by the density and divided by the gas constant and by the temperature. I suggest that we solve a problem using this formula. I'm going to tell you that we've taken an oily substance that's part of the eucalyptus plant, and at a temperature of 190 degrees Celsius, at a pressure of 799 kilopascals, the density of this substance, which is part of this oil, is 0.320 grams times a liter minus 1. What are we being asked? We're being asked to find the mass, the paint mass of this eucalyptus oil here. So what do we need? What formula do we use? Obviously this formula. Let's take it over and see what we need to do. We need to multiply the paint mass by P and divide by R and by T. Now let's see what the unknown is. The unknown is the paint mass. Then it's going to be d times the gas constant by the temperature and divided by P. Well, now let's remind ourselves that we are working with temperature. We are working in temperature versus temperature in Kelvin. Then the temperature needs to be converted. That would be 190 plus 273. Then the temperature in Kelvin would be 463 Kelvin. All. Now for substitution. For finding our mass, we have the paint masses. All the data is known, and we do the substitution. So we have D equal to 0,320 grams per liter minus the first multiplied by the gas constant with respect to kilopascals. It's going to be 8311444. 7 units of liter times kilopascal. Multiplied by Kelvin minus the first and the mole, minus 1. And temperature, which we converted to 463 Kelvin. At the bottom, we're going to have pressure, which is 799 kilopascal. Let's check that we have the units of measurement abbreviated correctly. The kilopascal is abbreviated, the Kelvin is abbreviated, so accordingly, we have the liter, and the liter is abbreviated, and we have the mass of paint in grams per mole, and that equals 154 whole and 0.2 grams multiplied by a mole minus 1. That's our answer. Then for this problem, it turns out we will use a nu for u quantity, which is used for gas, including, and as we have seen with you, this density is also connected with gas laws. So the formula that we have given today should be memorized, and then you will be able to solve these problems. Goodbye.